Backyard Professor Math videos. This is part 2, where I show you how to do the algebraic manipulation of an equation through multiplication and division. Let me state one thing. I believe in having fun in life, and I think math is one of the very funnest subjects I have ever studied. So instead of being dry and boring and pedantic and all that, I think it's fun to know the why, the how, the which, the when, etc., to understand mathematics, because it's so vital, it's so important that we as a free society continue knowing how to better our lives through the science and technology. Mathematics is the language of science and technology. We have to recognize that. We love our nice life. That comes at a price, the price of learning knowledge, real knowledge, good knowledge. The way math works with the natural world is one of the sensations of it. I showed you last time we use variables, x. We use variables, a. We use variables, they're letters, they're just letters, that's all they are. B, Z, R, N, F. It doesn't matter what variable. We use variables because we don't yet know the value of a number. Okay, it's that simple. That's what a variable is. That's why we use it in algebra. Sometimes we don't have the full information of the problem we want to solve, so we put the information that we don't know as a variable. For instance, x, and I'm going to use the dot for times. They used to use x, they used to do, in grade school, we said 4 times 3 is 12, and they used the x for the multiplication. In algebra, that can be confused with a variable, so we went to using either the dot, or another way to multiply is x4 or 4x. By simply writing the number next to the variable, you know that that's going to be multiplied together. Another way you can show multiplication in algebra is with parenthesis, either around the number or around the variable or around both of them. The parentheses are your friends. They clarify things. All of these expressions say x times 3, x times 3, x times 3, x times 3. And you'll see them written differently. Just understand that usually if a number is next to a variable, it's being multiplied. That is 3 multiplied by some number whose value we don't yet know. Okay? So don't let that confuse you. I'm going to use the dot just to clarify some things for now, and later on I'll use the other one. 3 times 3, or x times 3 equals 15. Now I'm going to make this simple. We know the answer here. I'm well aware that we know the answer here. But we want to start solving these equations with algebra, because I promise I'll show you equations that not even the PhD holders in mathematics can do in their head. And they'll be so easy to use and do once we understand the laws of how to use the rules. Someone has come along. Again, what's the step? We want x to be all by itself, right? We want to isolate the variable. I'm going to keep repeating that. Break that into your head. The first step, isolate your unknown, your variable. We don't know this one yet. We're going to find out. So someone came along and multiplied 3 to my x. I don't want it multiplied to my x. I want x alone. How do you get rid of a multiplied 3? You undo the multiplication. How do you do that? With division. You have x times 3, divide by 3. You divide by the same number that was multiplied to it, because the rule, the idea that we want to do, is we want to get this to equal 0 or 1. Actually, we want it to be 1, because anything multiplied by 1 is just that number. With addition, we want it to come to 0. In multiplication, we want it to go to 1. See, and trust me, you will make every mistake there is to make in math. That's okay. Everybody else has too. You really will. It's okay to make mistakes. I'll probably make stupid mistakes writing these videos, and you'll be able to laugh at me, but that's okay. What did I do? What did I do here? X times 3. I divided by 3. Now you can see it written this way, or some books will go like this. X times 3, they will divide it by 3. Right? You've seen that. That's the divide bar. Either way, it doesn't matter. That's division. We're dividing by 3, so we want to divide this side, the right side of the equation, by the same number. 15 divided by 3. This equals 15 divided by 3. Now this goes to 1, so this is x times 1 equals 15 divided by 3. Any number multiplied by 1 is just that number, right? I don't even have to show you. 5 times 1 is 5. 88 times 1 is 88. 397,000 multiplied by 1 is 397,000. So this just goes to 1. So that's how we've isolated the x. X, I'll put the arrow, x equals 5. 15 divided by 3 is 5. There's your answer. Now, x equals 5. So, you take the 5, plug it back into that x. You take the 5, put it back into that x. 5 times 3 equals 15. Absolutely. That's the beauty about algebra. You can actually check yourself. You don't have to have an answer sheet. You don't have to have the teacher come and check it. You can do it yourself. Isn't that cool? So we got rid of the multiplication through division by dividing. That's the key here. And it works for every equation, no matter what number. I'm picking easy numbers right now just to teach you the principle, right? Let's say we have n times 8 equals 16. We'll keep it simple. You already know the answer. And actually, they won't write it as n8. They'll write it as 8n. You put the number first, the variable next. When you don't put any sign in between them. 8n. n8, it doesn't matter. 8n is 16. 8 times some number is 16. How do we isolate n? Someone came along and multiplied my n by 8. I don't want it multiplied by 8. I want it by itself. How do you do that? You divide by 8. If you do something to this side of the equation, you have to do the same thing to this side of the equation, right? So this goes to 1, so this means n equals 8 into 16, or else 16 divided by 8 is 2. Then you take your 2 and you plug it right back into that n, so that you have 8 times 2, I'll put a parenthesis around it, equals 16. It's that simple. Isn't that astonishing? I love how this works. This is great. Now what about division? Yeah, all right, smart Alec, you showed us about multiplication, but what about division? That's a lot trickier, isn't it? No, it's not a lot trickier. Don't let the division wipe you out. Let's say we have C divided by 3 equals 12. And you look at that, and that starts freaking you out. And this is what freaked me out in 9th grade. I said, whoa, wait a minute, hold it. Why are you using a letter? Letters don't have values numerically. That's got to be a number. That's right, that is a number. We just don't know what its value is yet. So we're going to find out. Now, if someone multiplied something to your variable, you divided to isolate the variable. In this instance, someone came along and divided my c by 3. I don't want it divided by 3. I want c by itself. How do you undo the division? Through multiplication. Now I'm going to show you something. C over 3, c divided by 3, you multiply it times 3. I'm going to put the dot times 3 equals 12. But 12 also has to be multiplied by 3. What you do to one side, you do to the other. But let me show you something here. Every number is a fraction. It's a rational number. That's the definition. 5 is simply 5 over 1. 5 is a real fraction. That's not just a gimmick. 18 is really 18 over 1. 29,373 is really 29,373 over 1. Every whole number is also a fraction. The reason I show you this is because of this. I want to rewrite this. We have our variable c. It's been divided by 3. To undo the division, we are multiplying it by 3, but I want to multiply it by 3 over 1, which is the same thing as 3. Don't let the fraction-looking part fool you. That's just 3, right? Equals that's all I want you to see. I'm multiplying by 3, so I have to multiply 12 times 3 here. When you get to the fraction with the same number in the denominator, the bottom part of the fraction, and the numerator, if they're the same numbers, they cancel. And I will deal more with this in the fraction parts of my videos when I get to them. For now, just understand, the reason I wrote this 3 over 1 is because it's easier to see so I can cancel. The 3 cancels with the 3, and they each go to 1. Okay? Now, this is c over 1. Man, it's getting windy. This is c over 1, which is just c, and this is times 1 over 1, which is just 1. So this is c times 1. Any number, including a variable, that's multiplied by 1 is just that number. So I have isolated c all by itself. You see that? 12 times 3 is 36. So we know c equals 36. Then you take your answer, 36, and plug it back into c here. So when we see this number as 36 divided by 3 equals 12, that's correct. 36 divided by 3 does equal 12. So the idea here is just exactly like addition and subtraction. Multiplication and division are opposite operations. They undo each other. If you have 1/2, the simple fraction 1/2, and you want to turn this into the number 1, you multiply it by 2. which is just 2 over 1. And the reason you do it by 2 is because this 2 will cancel across with this 2. You can cancel diagonally to 1 and 1. And this says 1 over 1 times 1 over 1 equals 1 over 1. And 1 over 1 is simply 1. So you can see, to get rid of a divided number, a divided unit, you multiply. And to get rid of a multiplied number, 3 times 3, if you wanted to get rid of that multiplied number, you would divide it by 3. Because 3 over 3 cancels out to 1 over 1 because they're the same number here. And 3 times 1, 1 over 1, which is 3 times 1, is simply the number 3. So that's why division and multiplication are opposite operations, exactly like addition and subtraction are opposite operations. It's that simple. And that's how we isolate the variable. Let's do one more real quick. I think I've got enough time to do one more. Hopefully. Let's do 8d. You remember what that means. 8 times d equals 88. Okay? Now, someone has come along and multiplied 8 to my d. 8 is multiplied. I can put parenthesis to clarify that this is a multiplication, and do parenthesis around my variable also. I personally really like to do this. Later on, when we get into more complex equations, these parentheses become our best friends. They keep things organized and clear. Get used to doing it this way. You'll never be marked off by doing it this way. Every professor will know that you're multiplying this 8 by this variable. Equals 88. It's been multiplied by 8. I don't want it multiplied by 8. I want the d all by myself, all by itself. So to get rid of the multiplication, we divide it by that same number. 8 divided by 8 times d equals 88. Now, remember I just showed you. 8 over 8 goes to 1 times d, which is simply d. Any number multiplied by 1 is just that number. We don't know the value of this yet, so we're just going to say it's d. So it's d all by itself. It's been isolated. It's no longer 8d. I've been able to isolate it. The multiplication, I divided and isolated the d. But if I divide by 8 on this side, I have to divide by 8 on this side also. What you do to one side, you have to do to the other. And I'm not going to always emphasize it this way, but I just want you to get it clear. You must do the same thing to both sides of this operation every time, which of course is 11. Then you take the 11 and plug it back in there. 8 times 11 is indeed 88. So you know you got the right answer. Isn't that cool how that works? I think that's so fun. That's interesting how that works. When we get into more complex variables and equations, I mean, you're going to have, just to give you a preview of what I hope I can get to in these math videos down the road, this will be some time, you'll have stuff like this. 3x minus 8y plus 4z equals 1. That might freak you out at this point, and we'll get to where we can solve these, but you have 3 different variables here, 3 different unknowns. multiplied by some number to give you some answer. And we will learn how to isolate each one of those variables and get all of the variables on their side, on one side of this equals, and put all the other stuff on this side, and then we'll solve for each variable. But you see, can you figure that out in your head? Not likely. What if you have something like this? 89x divided by 63z plus 19u times 43m equals 9. Don't tell me, don't even pretend you're going to tell me that you can do that in your head. You can't. But through undoing, something's been divided, so we know we're going to be multiplying some stuff. Something's been added, so we know we're going to be subtracting some stuff. Something's been multiplied here, so we know we're going to be dividing some stuff. You see what I mean? If you understand the general principle, when we get to the point to where we're looking at equations like this, it's not going to bother you at all. It's okay. You know exactly what to do, step by step, systematically, logically, and you'll be solving stuff like this in no time. But first we begin with the baby steps. So anyway, thanks for watching my Backyard Professor Math videos. I hope they're going to help you. They're a great review for me also. I love doing these for that reason, because it reinforces it in my mind on how to do this. Algebra is the foundation for all of the higher math. Absolutely all of it. You will always be using algebra in algebra, geometry, trigonometry, pre-calculus, calculus, advanced calculus. So if we learn the foundation solid, the rest of it just kind of step by step, we just add more information, we do the same manipulation, we use the same principles and laws, and we work our way all the way up into calculus. It's that simple. It's complex, but it's very simple once you learn the laws. So, thanks for watching my Backyard Professor videos. Have a great life, and happy calculating.